Now we're going to talk a bit about evaluating screening tests. Screening tests are used in clinical practices to assess likelihood if a person has a particular medical condition. So the first thing we'll talk about is predictive values of screening tests. One of these is the positive predictive value and another is the negative predictive value. Positive predictive value is the probability that someone who has a positive screening test truly has the disease, whereas a negative predictive value is the probability that subjects with a negative screening test truly don't have the disease. So these are the two results that you want the probability to be as close to 1 as possible. Here's an example of a deep vein thrombosis. One method, the gold standard, is the venous Doppler ultrasound, and then the new test that we're comparing that gold standard to is a venography. So here we have a sample of 64,810 individuals. A certain amount did not have a deep DVT according to the venography, and 45 of those individuals did test positive with the venous Doppler. There was 1,115 subjects whose venography screening was positive, but only 132 actually had a DVT according to the gold standard of the venous Doppler. So from this, I started to fill in our 2x2 table, or a contingency table. So the total number of in the sample is 64,810. So that goes in the very bottom. The total of 63,695 that tested negative with the venography would go in the total column for negative venography. And 45 of those people did test positive with a venous Doppler, so that would get there. The venous Doppler, there was with a positive venography and a positive venous Doppler at 132 people, and a total of 1,115 had the positive venography test. So now to fill in these other ones, you would use the calculation. So 1,115 minus 132 would give you A, and here it's 983. Then B, we would subtract 63,695, take 45 out of that, so that would be 63,650. Just writing that in there for you. And then we can do C and D fairly easily. Adding 132 plus 45 is 177 here. And this does not correlate with the letters in the OR and RR. So I just used those same letters just because they're the first 4 letters of the alphabet. Those are not what we're going to use to calculate this. So then we add 983 to 63,650. We get 64,633. And if we added these bottom two together, we would also get this total amount here. So that's how we would fill this table out. Now, how do we determine this positive predictive value? Here we want to use the positive, those who were positive for the venography and the venous Doppler, so 132, divided by all of those who tested positive with our new test, so 1,115. So that would be 132 divided by 1,115. And this would come out to be a 0.118 or 11.8%. If we multiply it by 100, we would get 11.8%. So that means 11.8% of the time this venography predicted the true Venus Doppler result. Now, to get the negative predictive value, what we want to do is divide this negative Venus at intersection with the Venus Doppler negative and the venography negative, so the 63,650. We want to divide that by the total number that tested negative in the venography, so the 63,695. I'm not going to write that one out, but I'll draw a little division sign here. And it comes out to be 0.999, or 99.9%. So what does that mean? That means that in this sample, the venography exam and process was 99.9% effective at telling us that they would be negative if we used the Venus Doppler exam. So as a clinician, then maybe you would want to use whichever of these is cheaper, and maybe the venography is cheaper. So it may not tell you if a person has a DVT, but it will tell you if they do not have a DVT pretty accurately at 99.9%. So that's what we can take away from the positive and negative predictive values. There's some more screening tests we can use, including the sensitivity, specificity, false positive, and false negative. These are oftentimes calculated in conjunction with the positive and negative predictive values to determine what actually is, if it is truly going to be helpful clinically to use a specific test. So the sensitivity is screening positive when they truly do have the disease. Specificity is screening negative when they truly are disease-free. False positive is when they screen positive and they are disease-free. And the false negative would be they screen negative, but they have the disease. So those are some of the probability statements. You could also use 1 minus the specificity for false positive and 1 minus the sensitivity for a false negative. Here's an example of evaluating the sensitivity, specificity, false positive, and false negative. So in this example, we have a population of pregnant women who have a screening test to assess the likelihood of carrying a fetus with Down syndrome. So we have a gold standard test that is fairly has been screened and shows fairly regularly that this is accurate. And then we have our new screening test that on the left-hand side that's telling us maybe we're trying to see if this cheaper option will tell us the same results. So to calculate sensitivity, we want to calculate the probability of screening positive and in those who actually got the positive result. So it would be 9 out of 10, or 9 divided by 10, which would be 0.9 or 90%. Then we want to test the specificity, which is the screening negative, and they truly are negative. So they screened negative, which would be 4, well, you can't see this color very well, 4449 divided by 4,800. So the total number that is with a gold standard screened negative. And that would give us about 92.7%. Again, multiplying by 100 after we get that result. So now we want to calculate the false positive. How many people are getting a positive result when they truly do not have a child with Down syndrome? So here we're going to divide 351. Those people that on our new test screened positive, but truly were negative. So we have 351 divided by all of those who were negative, 4,800. And this is going to come back as 0.073 or 7.3%. And then the false negative would be those that screened negative but truly did have the disease. Or truly did have the Down syndrome. So the screening negative would be 1. The one person screened negative, but in the true gold standard did have Down syndrome, and then that would be divided by 10, and that would be 1/10 or 10%. Now you can see that we could have done 1 minus the specificity to get this false positive, and to get the false negative we could have done 1 minus the sensitivity. So these two go together, and the middle two, specificity and false negative, go together. So if you have to calculate one, if you need to calculate both, you can calculate one out and then do 1 minus the other, or in this case, since we're using percents, 100 minus the result to get the opposite. So if we have the specificity, we can find the false positive by doing the 100 minus 92.7%. So that's how you do these evaluating screen tests.